Okay, so hopefully you watched video 1 and also the previous 3 videos from the quiz, and now we're on to the last video, video 5, where we're going to cover absolute value graphs. A couple problems here to do. Okay, the first one, I have a graph, or an equation, and I want to graph it. So here's the equation, y equals -2 times the absolute value of x plus 3, close the absolute value, minus 1. Okay, so here's my equation I'm going to give you. Underneath it, even on the test, you should write the general form. Y equals a times the absolute value of x minus h plus k. And each of these a, h, and k means something. So let's talk about what they mean. First, let's talk about the a. Our a is -2. Negative means that this is going to open down. And the 2, since it is greater than 1, remember, ignore the negative. Since 2 is greater than 1, we are going to get narrower. Remember, we will treat this a as a slope, -2 over 1, and a slope of -2, that's a steeper slope, okay, so it gets narrower. Then let's talk about the shifting. The shifting here, h and k, we are going to shift. Remember that h goes in the opposite direction, so since it says +3, we're going to go to the left 3, and k goes in the same direction. So if k is -1, we go down 1. That was a terrible one, sorry. Down 1. Okay? So what the shifting tells you is the vertex. Remember, this is just the vertex. So I'm going to put this little note down here at the vertex. It's going to be at left 3, which is -3, and down 1, which is -1. Again, the vertex of the original graph is at the origin. So if we move 0, 0, left 3, that means the x becomes -3. If we move it down 1, the y becomes -1. So now we are going to draw a graph. Okay, go 5 in every direction. If I have to add more, I will. And now we will see that our vertex is -3, -1. Okay, and I will label it on top because I know I have to go down. And I'm going to go down 2, 1, 2, and to the right 1 and put a point. And then remember, there's this idea of symmetry. If we go down 2 and to the left 1, we'll get another point. And there's our v. Okay, so now we have to label the points. Let's do this one first. This is at -2, -3. And this point is at -1, 2, 3, 4, -4, -3. So there's a graph. So make sure you can identify these shiftings, these transformations as I call them. These guys right here are called transformations. Okay, transformations right here. All these. Okay. And then one more problem for us to do. Everybody's favorite pool shark problem. All right. So I'm going to set it up for you. You'll have a table drawn for you. So, excuse me. What I'll do is I'll draw a table right now. So here's my axes, if you remember from class. Then I'll use green. Here's my table. I'm going to make it a little bit longer. I'm going to make it as long as the... Here's my table. Okay, and remember, you're going to use 10-foot table, 10 by 5-foot table. Okay, and if you want to put in the corners, we'll put pockets in the corners. So you'll be given a picture like this. So then I'll tell you a couple things. All right, and I'll do it over here. Number 1. Your ball, okay, so you're going to sink the 8 ball, right? The 8 ball is at the coordinates 1, 3. The pocket you're aiming for, okay, the pocket that we are going to aim for is, the pocket we're going to aim for is this side pocket at 5, 5. So the side pocket. And the question is, if I try to bank it, so you have to bank it. So say you're playing somebody, and you have to bank it off a side. Bank it off the point. And this point is going to be 2, 0. The question is, will your ball go in the pocket? Will you be able to sink the A ball? So let's plot these on our picture. Okay, I'll use orange. Let's say that the ball is at 1, 3. So this is 5. So 1 is like here, 1, 3. So here's my ball. Okay, and the pocket I'm shooting for is 5, 5. So this right here is the pocket I'm going for. Okay, so the ball here, this is at 1, 3. The pocket I'm going for is 5, 5. So I'm going to bank it off of the side right here at 2, 0. So the question is, does this right here, this path, is that going to work? Okay, going off the side pocket, or off the side of the wall into the side pocket. So here, right here, is our vertex. Remember, that's our H and K. We don't know if the pocket is on our picture, or on our equation, but we do know that the ball is. So that's our x, y. So if we take the general equation, you can use f of x, we'll just use y. Y equals a times the absolute value of x minus h plus k. If you take x, y, and h and k and fill them in, we can solve for a, which is what we want to find. So we go 3 equals a times 1 minus 2 plus 0. Okay, well the plus 0 doesn't matter. So we get 3 equals a times, this is 1 minus 2, which is negative 1, and the absolute value of negative 1 is positive 1. And now we see that a times 1 is just a. This 1 doesn't matter. 3 equals a. So we have an equation, y equals 3 times the absolute value of x minus h, which is 2, plus, and the k is 0, so we don't add anything. So this is the equation we were looking for. This is the path of the ball, okay, from where the ball is resting to off the side rail. So the question now is, does 5, 5 fall in the path? Will we hit the side pocket? So now we plug 5, 5 in. Okay, so the question is, does 5, 5 work? So now we plug 5, 5 in. 5 equals 3 times the absolute value of 5 minus 2. And also we're checking to see if the left side equals the right side. We get 5 equals 3 times, now 5 minus 2 is 3, and the absolute value of 3 is 3. So here we get 5 equals 9. Uh-oh. Does 5 equal 9? Nope. So did we make the ball in the pocket? Does the pocket lie on the pathway of the ball? No. No. We missed. Okay? And again, it's because the coordinates of the pocket do not fall on the path of this absolute value. So if you take the pool table away, this is writing absolute value equations, right? You have a point and you have the vertex, and that's how you find the equation of the line of the absolute value, by finding the a value and rewriting it. Okay, so hopefully this video has helped. Again, after watching all 5, hopefully you're confident in tomorrow's test. Okay, we'll see you then. Bye.